Okay, let's do few practice from each gas law. I will do two question, maybe one question, then rest is homework or classwork. So some of the questions will be like a dimensional analysis question. Some of them will be applying direct gas laws. Let's read the question and realize which one is that. Okay, so first question on page number 20. It says calculate the volume of the balloon. So we are going to find the volume of balloon which has 0.881 moles. So we have moles and it says oxygen gas is at STP. So whenever you see STP and if it is asking for volume, the conversion factor you can use at STP, 1 mole of any gas, okay, will be equal to 22.4 liters. Okay, we have a conversion factor and we have only one number given. That means it is a dimension analysis question. Okay, so we are going to start the T chart starting from the given number, which is 0.881 moles of oxygen. Since it is moles of oxygen, you will convert moles of oxygen and it is asking for volume. We are using this conversion factor. 1 mole of oxygen at STP will be equal to 22.4 liter. So that's easy. If moles are converted into liter, so multiply, and there is only one on the bottom, so you don't need to divide, and you have to write 3 suffix, so it is 19.7 and unit is liters of oxygen. Okay, try the next one. Next one is also STP, so you can use the conversion factor. 1 mole is equal to 1 mole of a gas, only for gases, right, is equal to 22.4 liters. And since it is given in gram, we know the conversion gram to mole, right? 1 mole of helium will be, look at the periodic table, it is 4 gram of helium. So 2 conversion factor. And again start the T chart. This time since it is in gram, you need multiple steps. So you are going to write 2000 grams of helium. And to convert that into moles, you have to divide with the molar mass, which is 4 gram of helium is in 1 mole of helium. Now you have mole, so you will write 1 mole of helium will be occupying 22.4 liters. So then multiply and divide. So you have to write the answer in 1 suffix, right? So it is 10,000. Since it's, you will get 11,000 something in your calculator, but you have to round that to 1 suffix, so that is liters of helium. That is the answer. Okay, so those are the type of question you might see when it is not directly asking applying gas law. But look at this next question. Okay, I'll skip that and I will do number 4. Okay, a container holds 12.0 liters, so that is a volume, and there is a mole, again number of moles, and it is again asking for moles. That means there is a change. So I will write this one is N2, N1, and this one to N2. N1 is the initial moles. After changing, it will be N2. So this will be V1 and 20.0 liter will be V2. Okay, so V and N, the relation we learned, we know that it is V1 over N1. They are proportionals, right? Will be always equal to V2 over N2. Substitute V1 is equal to, make sure all the variables are in the liters, 12.0 liter. Then N1 is 3.0 mole. Only thing you have to worry about the units needs to match. And we don't know N2, so I'm writing N2, or you can put X there. That's up to you, okay? Then write, no, N2 is gone the bottom, oh, sorry. So it is V2 is 20.0 liter, then N2 is what? We don't know, Okay, now the calculation, some of you have a problem with that. Okay, just remember the cross multiplication. You have to multiply this one first, then divide with this number, right? So it will be 20 times 3, it's 60 divided by 12. You don't need a calculator. So the answer is what? It is 5. But there are all numbers. This one has 3 sig fig, 2 sig fig, 2 sig fig, multiplication and division. The sig fig rule is lowest sig fig, so you need 2 and the unit is small. That is the answer. Okay, now you all of the other questions are same thing, just do. Next, let's go to the Boyles law one. It won't say Boyles law or Charles law on your test. You have to figure it out, okay? This question says a gas has a volume. So I'm going to write V1 assuming it is initial and final. And ATM means it is a pressure, write P1. Then you are going to find the pressure increased to P2 and you are going to find the final volume. Okay, we know that volume and pressure are inversely proportional according to Boyle's law. So the equation will be P1 V1, P times V1, okay? P times V will be equal to P2 V2. Substitute. Sorry, I left my cheese on the it's So we have to substitute. The P2 is 2.0 ATM times 4.0 liter, which will be equal to P2, which is 4.0 ATM times, we don't know V2, just put X or V2. Now the calculation part, some of you have problem with algebra. You will multiply these two, then divide with what? 4. It is very easy calculation. The answer will be what? Answer will be, yeah, it is 2 because 4 and 4 cancel. You don't need to use the calculator, right? So V2 will be what? How many sig fig? We need 2 sig fig, so it will be 2.0 lit. Okay, that is the Boyle's law. I'm skipping everything. I'll go to the next type. Okay, so whenever we learn, we will never use temperature in degrees Celsius, okay? Temperature must be in Kelvin while doing the calculation because all gas law relations we can explain only in Kelvin, or if you put degrees Celsius, sometimes there is 0. Just think like that, okay? Then the answer will become 0. Okay, let's see this. It has volume, it is V1, temperature T1, and there is another temperature T2, and you are going to find the final volume. And the relation, they are directly proportional, so V1 T1 is equal to V2 T2. Okay, substitute 4.0 liter over 250 Kelvin. Temperature is already in Kelvin here, so I will do another question with a different one. Then V2, this is V2. V2 over 500 Kelvin. Okay, now the calculation part, you multiply these two, then divide with the 250, and your answer will be 8. And how many sig fig? There is only one here, so we will go with one sig fig. The answer is 8 and the unit is liter. This is how we are getting units. Like Kelvin and Kelvin, you can cross it out. There is only one unit remaining, which is L. Okay, let's do another one. I'm gonna find one question which has degrees Celsius on it. Okay, let's do number 5. Okay, so number 5, there is a volume for 25 ml and T1 is 125 degrees Celsius. So you have to add 273 into it and convert that into Kelvin, which is 398 Kelvin. Okay, that is a conversion factor. And 25 also converted into 270 by adding 273, which will be 298 Kelvin. Okay, now substitute. You don't need to worry about the volumes unit. If it is in ml, your final answer will be in ml. That's it. For this initial and final, you don't need to worry about. So it will be 398 Kelvin, and which will be equal to we don't know what is V2 is, then divided by 298 Kelvin. Okay, now get your calculator and multiply these two, then they divide with 398 and you will get the answer 318 and 3 sig, and it will be what? Not Kelvin, it is milliliter. That much milliliter, right? Because this Kelvin and Kelvin gone, then only unit remaining here is milliliter. Okay, then Gay-Lussac, here also we know that there is using temperature must be in Kelvin. I'll go pick one question which has degrees Celsius in it. There is one here, maybe I'll do number 6. Okay, so here pressure 1.5 atm, that is a P1, and temperature is T1, and add 273 into 8, okay, which is question number 6. Okay, then you will get 250 Kelvin, that is your T1. And you have to find the temperature in degrees Celsius, that is also another problem. Okay, let's go see how can we do this. This is P2, okay, then equation is P1 over T1 is equal to P2 over T2, right? Then P1 is 1.50 atm over T1 is 250 Kelvin and P2 is 3.0 atm, and temperature we don't know, just put T2. Okay, now calculate it. Okay, so when you calculate it, you are multiplying, you are multiplying these two, then divide with this, or you can just 1.5 and 3, it is 2 times 250, like that you can do it. So then you will get your answer. Okay, then you have to do what? You will get 500. You will get 500, but look at the unit remaining. Your answer is in Kelvin, so minus 273 to get the degrees Celsius. That's how you have to do it. Okay, now let's see the next topic, which is combined gas.